All right, let's get started. There we go. How's everybody doing today? Great. Awesome. Well, good afternoon, everyone. I am looking forward to this software-defined data center futures. I'm Jeff Woolsey. I'm a principal program manager in Windows Server. It's a pleasure to be here. I'm joined by my awesome colleague, Mr. Klaus Jorgensen.
Hey.
How many of you guys know Klaus? Yeah? We have a lot to talk about. I've done sessions on hybrid. I've talked a lot about containers. But one of the things we haven't really, at least I haven't talked about too much yet, has been our software-defined data center futures. And I'm thrilled to be here with Klaus, because when I think of storage and I think of what we're doing in Storage Spaces Direct and some massive innovation we're doing here, Klaus is the guy I'm definitely going to lean on in that area. So let's get started. Quick recap on some of the things we did on 2016, which is going to set the stage. You're going to see how it allows us to go forward in the future releases and where we're going in the insider previews. So for Server 2016, it's the cloud-ready server operating system that delivers new layers of security and Azure innovation. And the point I want to make around Azure is, number one, let's not forget, Windows Server is what powers Azure. And the work that we're doing in compute, in storage, and networking is work that all accrues up in Azure. And Azure will literally come to us with feature and technology requirements. One of my favorite ones is, for example, around performance and scale. So in 2016, we support the largest, biggest, baddest systems. That was all requested by Azure. You just happened to get it. In the case of Azure Stack, one of the questions I keep getting asked is, hey, Jeff, when are you going to put that shielded VM stuff into Azure Stack? And the point I always like to make is, well, you need to understand the relationships here. Windows Server feeds into Azure, but Azure is what drives Azure Stack. Okay, so the Azure Stack team is taking their cues directly from Azure. So as new services, new technologies, new features come alive from Azure, you'll see those start to go down into Azure Stack. And again, both Azure Stack and Azure feed requirements into us. And so that's how that relationship works. Well, the beauty of that is, as we build in new security features into the core kernel, Azure gets those and Azure Stack gets those. We made huge advancements in things like Credential Guard, Remote Credential Guard, Device Guard, all of these things, shielded VMs, securing the virtualization platform itself, doing things and using virtualization to innovate in new ways beyond what anyone has done with virtualization. The virtualization-based security that we built into both Windows 10 and Server 2016 allows us to completely kill some types of attack vectors. For example, pass the hash and pass the ticket. Those have been attack vectors that have been very difficult for us to try and countermand. And the way we did it was to simply invent a brand new technology, virtualization-based security. And quite literally, that only exists if you're running Server 2016 and Windows 10, and if you're running on hardware, or if you're running it on Hyper-V, or of course, if you're running it in Azure Stack. That allows us to completely mitigate and kill pass the hash and pass the ticket types of attacks. These built-in layers of security go on throughout the kernel. Then the work that we've done for Azure-inspired infrastructure, whether it's been compute, storage, networking, we're going to drill into that further. And then, of course, the work we've done in the hybrid application platform. We're not going to focus on that in this session, but that's the work we've been doing in containers and Hyper-V isolation, and in fact, in the new Linux containers we've developed in 1709. So we continue to work. These are the three pillars that we focused on for 2016. When you look at the software-defined data center, there's a tremendous amount of new features and capabilities. And folks, this is just barely scratching the surface. I literally have slides that have literally just columns and columns and columns and columns of features that are in 2016. Rolling upgrades, hot add remove NICs, hot add remove memory, more resiliency in terms of compute. For networking, we brought a whole bunch of the capabilities that we use up in Azure, some of it Azure inspired, some of it directly Azure code from the software-defined networking that we've been running up in Azure, which has been tested at planetary scale. So when you see things like the Rio Olympics, the Sochi Olympics, that are powered by Azure, that's all powered using our software-defined networking. And we literally are live streaming 1080p around the world to hundreds of millions of users, and it just works on our software-defined networking. Well, that's the kind of technology we brought back into Server 2016. The same Azure data plane is in 2016 that we run in Azure. Network load balancer, distributed firewall, network controller, and so much more. Storage. We're going to spend a lot of time on storage today. 2016 was huge because it was our big introduction to hyper-converged deployments and infrastructure in 2016. We'll talk exactly about what that means. Also, inbox replication. I believe Ned was right ahead of us talking about storage replica. That's been a long requested feature. Thrilled to have that in the box. Previous to 2016, that was something you would simply have to pay extra for from someone else as an add-on. Now we have both synchronous and asynchronous replication built into the box in 2016. RDS, major enhancements as well there, supporting the most heavy graphics workload, even requiring the latest OpenGL, OpenCL, and of course this accrues up in Azure as well. So these are just a few of the things we've done in Server 2016. And if you want to know more, you can certainly check out past Ignites and Channel 9 and YouTube, and you find a lot more. Now, when it comes to the Azure-inspired networking, I've mentioned most of these. Moving fast with the network controller. One of the things I like to point out is, look, we understand that we live in a hybrid world. We live in a heterogeneous world. You've seen all the work that we've been doing to embrace open source. You've seen all the work that we're doing Linux. You want to run Linux, you want to run open source, you want to run whatever. Runs great on Azure, runs great on Hyper-V, runs great on Windows Server. We have Linux containers in Windows Server now. We have WSL in 1709, so you can run Bash in there to doing Bash automation. But also, in terms of networking, we actually have VXLAN support. So if people that have deployed VMware and they're using VXLAN, in Windows Server, we had support for NVGRE. Well, we added support for VXLAN. And honestly, we don't care what type. These are both different networking overlay protocols. At the end of the day, we don't care which one you use. This shouldn't be a Betamax versus VHS conversation. The important thing is that you're using software-defined networking. So we support them both. So if you have VMware in your infrastructure and you want to incorporate Hyper-V and our software-defined networking, you can. And you can use our gateways as well. Our distributed firewall, network security groups for microsegmentation. Microsegmentation is a great way to segment down workloads to prevent access to broader orgs and keep things extremely isolated. Routing and mirroring, and of course the work that we've done to reduce costs. And reducing costs has been about making sure that we can reduce the number of physical NICs that you've needed. So we now support converged NICs that allow you to use RDMA and Ethernet traffic on the same teamed NICs. So instead of needing 4 NICs, you only need 2, but on top of that, you get the ridiculous performance of RDMA, and you get it with very little to no extra CPU overhead. And this continues to be one of the major advantages that Windows Server has over any other platforms out there doing hyper-converged. They still don't have an RDMA story. We've been doing RDMA since Windows Server 2012. We introduced it back then for our file server. In 2012 R2, we added support to Hyper-V. You could do live migrations over RDMA. And in 2016, we've done even more, and we'll talk a lot about that. Of course, QoS for predictable performance and additional work around monitoring automation to reduce OpEx. And the interesting thing to point out around SDN is from an operational standpoint, it's really allowed people to do things much quicker. And this is a perfect example. The ability to spin up a software-defined network in about 8 minutes while eliminating a $20,000 cost is a huge benefit. This task used to take over 2 weeks on average. Think about that for a second. 2 weeks to deploy a new network? Yeah, because you got to configure all these switches, and heaven forbid you do something wrong in a routing table or you fat finger some mistake, and all of a sudden people don't have access on a certain part of the network. With SDN, create these nice big flat networks and use SDN overlays to do all of your segmentation and routing, and you let the software figure it out. Spoiler alert, that's how we do it in Azure. You don't seriously think that there's someone in Azure who's typing things into switches, right? And like logging in and like fat fingering IP addresses and ports and gateways. That's not how this works. It's a big flat network, and we use SDN to manage all of this at massive global scale. No reason why you can't do this on premises, and that's what we're doing with SDN. Also want to point out some work we've been doing with our friends over at Intel, and this also goes to the state of storage. Storage is in a massive transition right now. And honestly, I feel like I've been waiting for this all of my life. Compute's been rocking fast, memory's been rocking fast, networking and storage seem like they've been kind of pulling up the rear for quite a while here. In storage, we have been limited by the fact that there's been spinning media and a little read-write head going across a spinning platter for decades. Now we've got flash, and now we're doing all sorts of interesting things with flash. First thing we did was, hey, let's take that spinning thing and put flash in there instead. Then we said, hey, let's put a new interface on there. Let's not just use SATA or serial attached SCSI, let's put NVMe. Well, now we're taking another step further, NVDIMMs. So now you're actually taking flash and you're putting it in a DIMM socket where the performance is even closer, where the location is actually closer to the processor, and you can treat it as memory. So we're working very closely in the industry around NVDIMM support. Intel is one example. We're working with them and recognize that people should be looking at developers should be looking at NVDIMM support because you may want to rethink and re-architect how you think about managing memory with this new type of flash storage. Okay, so it's going to open up new opportunities. Today, servers have, tens, sometimes hundreds, maybe even a few terabytes of memory. Well, what happens when you put in these NVDIMMs and all of a sudden your server has 50 terabytes of NVDIMM memory? What does that mean? All of a sudden, the world of AI and machine learning gets very, very interesting there. So there's some, you can check out this on the show floor and with our partners as well, HP. And then finally, the last thing I want to point out is this is something new that happened since the launch of 2016, was the introduction of support for SATA DOM in Windows Server 2016. So for years, I've had people telling me, Jeff, I really, really, really wish Windows Server would support booting off an SD card. Oh, no, you don't. No, you don't. Jeff, I really, really wish Windows Server would support booting off a USB 2 device. No, you really don't. What you're asking me is, Jeff, I wish I didn't have to use a storage spot in my server for boot. That's what you're really asking me. You're saying, Jeff, I really wish instead of using that for boot, I could use that storage spot to put in another SSD to run more VMs or more storage. And what I really want is to not take up a physical slot to put storage in there. SATA DOMs are a much better solution. So now this is flash, very small flash you can see, and it literally, instead of plugging in USB or plugging into SD and using really, really slow performing flash, it uses really high performing flash that plugs directly into your SATA port. And that's like 128 gigabytes right there. Okay? So you plug that into your SATA port, and guess what? There's where you put the OS boot. You want to boot the OS? Great, boot from there. And now we've freed up that slot that you wanted, so now you can put your VMs and your storage there. Now we're good. Because for those people that have actually gotten SD to boot and actually booted a server up off SD, they said, yes, I got it to work, but boot now takes 5 minutes. Yeah, because that storage is really, really slow storage. This is really fast. So this is brand new, this is available, and this works for 2016. You can take a look at the endurance, performance, capacity requirements there. And if you want to look for these devices, go up to the Windows Server catalog and you'll find supported SATA DOMs there. So with that, I'm going to pass it on over to Klaus. Klaus, on the Storage Spaces Direct.
Thank you, Jeff. So how many here already know about Storage Spaces Direct? Awesome. I think I did a reasonably good job last year talking about it. Here's a quick recap. So Storage Spaces Direct, we take a handful, in this case 3 servers, put them together, use the internal storage that is inside each server, and pull that together to create a highly available, scalable storage system. Now, oops. One thing I want to point out is we love NVMe devices because they give us better performance and efficiency. I'll give you a quick update on that in a second. We still support SATA devices for lower cost, as well as Ethernet and RDMA. We want to use that for Storage Fabric. I'm pointing in the wrong direction. So the scenarios, don't forget, is that you can actually use Storage Spaces Direct to back SMB3 file shares. So it's a scale-out file server serving Hyper-V servers that are sitting outside, SQL servers that are sitting outside, or other workloads like that. We support hyperconverged, which is probably the most popular deployment mechanism right now, where we have VMs that run on the exact same servers as where we run our Storage Spaces Direct. Or you can also do SQL Server straight on the Storage Spaces Direct system. So those are the most common deployments. So why is NVMe important? NVMe is important. If you take a look at it, here is some relatively old devices, but the truth still stands. This is an exercise we did a couple of years back. So take a look. On the left, we have an NVMe device. It costs you $1.62 per gigabyte, and a SATA device with the same capacity costs 98 cents. Obviously, I should use the SATA device. right? Gives me more capacity per dollar. However, if we look at the device and see how much I/O can I do on that particular device, the NVMe quite clearly beat the SATA device. So if you redo the calculation, it comes down to half the cost if you measure it per IOPS instead of gigabyte. So if you have a system that needs really good performance and not necessarily just capacity, then NVMe is an obvious choice. But it's not all that either. Every I/O needs some CPU assist, right? The CPU is involved in doing I/O. So the amount of CPU on this particular system that was required to drive 100,000 IOPS on a SATA device was 37%. Go do the same exercise on the NVMe device, it's 19%. Hey, wait a minute, I just effectively got 18% of CPU back that I could use for my SQL Server, what have you not, that is running on the system. What's not to like? RDME, what is that? I don't know. RDMA is important. And it's important because it is the fabric that we use between the servers when we do what we call the east-west traffic. Because when you have a software-defined storage systems where you have storage devices in individual nodes, guess what? We have to write data out across nodes to make sure that it is resilient. RDMA allows us to largely bypass the CPU in doing this exercise. So if you look at how many IOPS can I get using 1% of the CPU in this particular combination, with a traditional Ethernet adapter, in this system, I got 12,800. Using RDMA, I got 16,300. So that's another 27% without changing the CPU. All I did was just use RDMA instead of not. Look at the reverse part is, what is the I/O latency doing with RDMA? So without it, it's 390 microseconds, and we measured it down to 250. So that's a 36% reduction in I/O latency simply by using a different transport in RDMA than traditional Ethernet. So if you really need to have things go fast, RDMA is the answer to that. And we are absolutely happy that there are many partners to choose from that provides various RDMA adapters across the two most popular implementations, which is RDMA iWarp or RDMA Rocky. Now, building these systems yourself can be a rather complex endeavor where you have to find out many components, et cetera, and figure out if it all works together. So to make that easy, we have collaborated with a bunch of our partners in actually building systems that you can just buy as is and then deploy in your data center. And that's what we call the Windows Server Software-Defined Program. And what that does is basically we've created a reference architecture that we communicated to our OEM partners. They've used read through that reference architecture and devise a system, and then they take and validate that system against a bunch of testing and requiring validation, and then they do some deployment automation so you can quickly use that in the market. And there is a bunch of our partners that is already shipping Windows Server 2016 on qualified hardware, and we add more all the time. There is a site you can go to see more details, as well as we also have a poster describing the entire program and all the technologies that go into Windows Server Software Defined. We've collaborated with Intel, and Intel has another program called Intel Select Solutions. These solutions are validated from Intel's perspective, including benchmarks that they communicate, so it becomes really easy for partners that are building systems based on Intel technology to take it through the Windows Server Software-Defined Program and for the customers to understand what they can expect from solutions built based on that. Now, with us today, we have Benjamin and Alan sitting right here. They've been doing deployment at youth villages, and they'll be happy to take questions afterwards. Youth Villages is a private, nonprofit organization who needed better performance in their medical recording system. And they chose Storage Spaces Direct with an all-flash configuration to do that. And Youth Villages is helping emotionally challenged children across the United States to come to lead as much as you can a normal life. So that is a really important thing, and I'm super proud to be just a tiny bit involved in that effort. So they chose one of the Windows Server software-defined offerings based on data on and an all-flash configuration running the must interface. And we have a short video from Youth Villages. So
we've been working with Youth Villages for 21 plus years. They're a great organization, and we've always had a heart for Youth Villages and what they do.
Youth Villages is a private, not-for-profit organization. We serve in 13 different states across the country, and we operate in 72 different physical locations. We have about 2,800 employees who work with emotionally troubled young people and their families. We actually implemented a full electronic medical record system over 25 years ago. Technology is just part of who we are. Part of our culture here at Youth Villages is the use of technology to further being effective serving young people and their families.
Microsoft started announcing that they were going to be coming out with their storage spaces direct. I started getting really excited. Microsoft is bringing enterprise storage SAN solutions to the masses in a way that they couldn't afford a year ago. Data On is taking Microsoft's great solution and saying, we're going to make it a complete storage solution with support, with maintenance, with visibility, with monitoring.
We have much happier employees. They're able to spend their time now not waiting on systems that are slow, but instead can spend their time working with the young people and families that we serve.
all right, thank you. Now to the futures. That's probably why you're here. So, Jeff?
Let's do that. So let's start with software-defined compute and networking. So when it comes to the software-defined data center, there's a lot more to come. When it comes to the compute side, you'll notice you're going to see Honolulu integration a lot. How many of you guys have seen Honolulu this week? Yes? Oh, good chunk of you have. Most of you have. I'm surprised actually at how many haven't. We got to fix that. Shielded VMs has been extremely popular. I cannot underestimate what has gone on with shielded VMs. When we actually launched Server 2016, I was in London with one of our service provider partners who was proud to say that on day one, they were there providing shielded VMs for their customers. And in fact, they weren't doing it at any additional cost. They basically wanted to be able to tell customers, if you want to run on BrightSolid, if you want to run on their hosting provider platform, you could use a Windows Server VM, or you could choose a shielded VM. And if you chose a shielded VM, make sure you took good care of that key, because if something happened to it, they couldn't help you. Customers love that. Like, wait a minute, you can't help me. Right, I can't get inside the VM. If it's a normal VM, sure, I can get inside the VM, because I'm the hoster, I can do whatever I want. But if it's a shielded VM, nope, you better take good care of that key, because in fact, it's encrypted and you, the customer, has it. In fact, it's a top request for Azure. Azure has the same, they want to make the same guarantee. If you go up to Azure, you can create a VM. Well, what if you could go up there and go to Azure IaaS and create a shielded VM that says, hey, here's the key, take good care of it, because guess what? If something happens to it, Microsoft can't help you. We can't get inside, you own the key. So people want to be able to deliver that type of promise, that type of isolation, that type of guarantee. Well, Server 2016 brought that to Windows VMs. But we've been doing a ton of work in the open source community, and one of the things we're doing is we're enabling shielded Linux VMs going forward. We want to be able to make that promise whether you're running Red Hat, Ubuntu, Debian, you name it, so that you can do the same exact thing with Linux VMs. So RDMA, you know, I love the investments we're making in RDMA. Klaus talked about the work it helps for reducing CPU overhead. It's fantastic for east-west traffic. One of the things you have to remember is, in a hyper-converged deployment, say you've got 4 servers, okay? Keep in mind there's no shared storage. That shared storage is happening. What happens is a write occurs on node 1, but it also writes to 2 other locations simultaneously. So there's a single local write, and there's 2 remote writes. We're writing to 3 locations simultaneously. Well, as Klaus mentions, of course, as you do an I/O write, well, there's CPU overhead. Well, if I'm not only writing a local write, but I'm doing 2 additional extra writes, that adds up real quickly. RDMA, that becomes largely free. Well, think about workloads that are write-intensive. Databases, for example. You're doing some work, and all of a sudden you have a single VM on node 1 that gets intensely write-intensive. It's doing all of a sudden 70% writes. Well, guess what? Those got to be copied to those other nodes as fast as possible. That's one of the reasons we require 10 gigabit. But again, if you're not using RDMA, the CPU has to handle all that. Well, those writes on a 10 gigabit NIC can easily consume a core or two on a modern day processor. So think about what just happened to the overall scalability of your hyperconverged infrastructure if you're not using RDMA. That's why the work that Klaus and team has been doing has been so important, because it means SQL can go as crazy write-intensive as it wants, and it doesn't impact the overall performance of your cluster. Well, now we're doing this from the guest side. So imagine you're running a workload like SQL in a VM, and you want to use RDMA inside the VM. So now we can do that with minimal to no overhead inside the guest as well. So we're continuing to what we call enlighten that stack, not only the host side, but the guest side as well, to give you the best possible performance with minimal CPU overhead. On the network side, yeah, you're going to see a lot more Honolulu integration there as well. Encrypted virtual networks. We want to make it easy. We've done shielded VMs. We've got shielded disks. We have encrypted disks going back 10 years called BitLocker. I know the other guys are off congratulating themselves in version 6.5 for doing encrypted disks. That's what we did in BitLocker 10 years ago. Congratulations, guys. Well, encrypted virtual networks are the same thing. We want to make it dead simple. Let's just encrypt a virtual network and make it as simple and as easy as possible. So you're going to see us continue to ease that. NTLM for clusters. Oh, no longer required. Let's get rid of NTLM wherever we can. And then, of course, thank you. Yeah. It's always surprising when you hear a clap for something like they're like, oh, please, yes, kill it with fire, Jeff. Kill it with fire. Make it go away. Fax server, kill that thing, right? We all good on that? Yes? Yes, please. I heard a yes, please. Thank you. I'm telling you right now, I am killing fax server. It is not coming back. It is not coming back. SMB1 disabled by default. If any of you follow, yes. Could not be more thrilled. If you all follow Ned Pyle on Twitter, or if you just know Ned, he has been trying to kill this thing with not only fire, but napalm for quite a while. And it is disabled in 1709 and going forward. So that is not going to be on by default. We want to do that. So these are just some common sense defaults that we want to do, but we're going to be adding more in terms of networking. And in terms of Honolulu, I am going to do a quick demo. I know a few of you have mentioned you've seen it, so I won't spend too much time. But there's a couple questions that I've been asked about Honolulu, starting with, hey, Jeff, if I deploy the technical preview, how do I update it? Spoiler alert, there's an update button. The Honolulu team has been fantastic, okay? I sit with these guys, and I give them bug requests, I give them feature requests. I log bugs all the time, and literally within a day or two, hey, Jeff, we got a new build, it's all fixed, all taken care of, all set. It's come right back at you. So I sit down, and I'm like, great, log some more bugs. A couple days later, here's new builds. So the reason why Honolulu is as its own technical preview and why it's separate is because we want to iterate quickly. So please join the insiders group, start downloading Honolulu, because you're going to see us update it. Imagine we get this to you, new features every single month. Okay? I can tell you, as someone who's been working closely with these guys for many, many months, that's exactly what I've been seeing. New features constantly. And one of the features, like I said, I've been asked about is, well, what happens when an update comes out? Well, there's an update button right there. The other thing I want to point out is the extensibility factor. I think one of the greatest things about Honolulu is we don't just think of this as a free tool or a product. We think of this as a management platform. What it means is it's extensible. And so when I click over here on the settings button in Honolulu, you'll notice I can see the available and the installed extensions. Well, spoiler alert, every one of those icons on the left-hand side is a plugin. This is all written in JavaScript. All pluggable. So literally, as I've been working with the team over the last many, many months, we've had 6 icons. They give me a new version. Wait a minute, there's 8 icons. What's in here? Now I have 10 icons. Oh, whoa, what's in here, guys? And so we've been literally adding new features non-stop. And by the way, if you want to remove things, if you say, hey, you know what? I've got someone that I don't want to give them access to the network, guess what? I can uninstall that as well. So the extension manager is something that's part and parcel of Honolulu. The other thing I want to point out are the different views of Honolulu. I've had people really focused on the server manager part or the HCI, the hyperconverged infrastructure part. But I want to point out that it actually does a number of different things. Server manager here is designed itself to be better than those tools that you're used to using. Task manager, event viewer, device manager, registry editor, where you're constantly switching from one context to the next and all of these different views using different versions and different looks based on when that tool was written. Failover cluster manager, pretty obvious what that's going to do. But hyperconverged cluster manager is all about delivering something brand new. So in the past, if you wanted to manage lots of servers, 4 servers, 8 servers, 12, or lots and lots and lots more servers, you got to do something like System Center. And if you do want to deploy racks of servers, System Center is still the way to go. But for a lot of people that are moving to the cloud, and they say, you know what, I'm doing more of my Office 365, I'm doing my SharePoint, I'm doing my mail up there, but there's still some apps that I want on premises. So you know what, I just like to roll in 4 servers, 8 servers, okay, and just roll them in here. Well, I'd like to be able to say, you know what, roll those in here, all running server core with no GUI, and hand you a Surface. And say, manage this all from a touch-friendly world, which is exactly what I'm doing here, by the way. This is all running on my Surface Pro 3, nothing special, all running locally here. And the machines I'm talking to are literally sitting under my desk back in Redmond, Washington. Okay? This is all agentless. Okay? So literally clicking on a machine takes me right to that machine. And those tools that I'm used to needing to go to, context switching, for example, Task Manager, well, the overview is right here. I can see my CPU utilization, my memory utilization, et cetera. If I want to actually edit my files, change directories, do all of those things, I can do that as well. If I want to take a look at my storage, you notice storage integration here. I can see my disks, my volumes. I can format volumes. I can create volumes. I can format disks, all of that here. Storage replica, I haven't configured it here, but if I had storage replica configured here, yeah, I can configure replication and replicate and handle that replication all through Honolulu. And of course, when you get to things like Windows Update, yeah, I can manage these. I can click on Windows Update, take me to Windows Update. It'll show me all of the lists, all of the updates that I need to install, and I can do all of this remotely. And the thing, again, I want to point out is this is remote management. This is all of these servers I'm talking to are GUI lists. There is no GUI I'm running on those. My goal is to make sure that those things that you're commonly needing to do, those common tools, are all handled here. For example, if I need to take a look at the events on this server, for example, I want to go check out my security log, head on over here to Windows Logs, click on Security, and lo and behold, I get this nice long list. If I want to filter this further, let's get rid of information in verbose, quickly filter this down, and in fact, instead of having 90,000 events to look through, oh, I only have one error to take a look at. So, I'm sorry, I missed. Oh, registry editor? Someone wants to see the registry? Gosh, there's always someone, huh? Who doesn't want to see the registry, right? Yeah, folks. Did you want to see the registry? Yeah, you can see the registry. How about devices, by the way? Ever try to check your devices on a GUI-less server running remotely? Good luck with that. It's not the easiest thing in the world, but with Honolulu, guess what? Here it is, and if you want to see the details, for example, I'm not going to look at a floppy controller. Good Lord, it's not 1995. Here's an Ethernet adapter. Here is the driver. Here are the details. And I can dig into the details on this device. Finally, when it comes to looking at virtual machines, if I head on over here to node 4, where I'm running quite a few VMs, I'm running 4 VMs in my inventory. You can see I've got them all running. I've got one running server 2012 R2, running one 10, 2012 R2. These are all running remotely. If I want to dig into one of those, like click on my Windows 10, now I get the further information and details on this one. Here's the operating system it's running. Here's the memory demand. Here's the integration services. Here are the things that are doing. I can look at the disk. You can see that this is a dynamic disk, and 38% of this is used. So already we're showing you more than Hyper-V Manager ever had. Okay, and we're showing you all of this from this easy-to-use console. And one of the questions I keep getting asked about Honolulu is, where is this installed? Where can it be installed? It actually can be installed in a bunch of places. For this example, I'm literally running it on my Surface. I literally double-clicked on an MSI, loaded up here, and in 30 seconds, these servers are under management. If I didn't want to do that, I could have installed Honolulu on any one of those 4 servers or all of those servers running in my office. Okay, even though it's running headless, I could have installed it there. I could also set up a single server as just a Honolulu server, a web server, and could have done that as well. So it gives you the flexibility to deploy this very lightweight, this very easy to use. So finally, hyper-converged. So with the hyper-converged cluster manager, what this enables now is a whole new type of management that we really haven't had in the box. Now we're talking about managing across servers. Okay, what I just showed you in the server manager was when I need to go to a specific server and look inside a specific registry, or update a specific directory, or add a role or a feature to a specific server. Here in the hyper-converged cluster manager, you're actually seeing all of your nodes. So the first thing I want to highlight is it's the hyper-converged cluster manager. The second thing I want to point out is when I log into the dashboard, it actually gives me alerts for all of the systems in the cluster. So this is a 4-node cluster, and it's telling me, hey, guess what? You've got some low storage here. You're running low on available storage. If I go to this blue highlighted area, I'm actually seeing my overall cluster performance. Okay, you've never had this without going to System Center before. This is all showing me my IOPS performance, my latency, my throughput, and you'll notice on the right-hand side, it's hour, day, week, month, year. One of the smart things that the HCI team did is when you enable HCI and you enable storage spaces direct, we turn on all of the historical event logging. So when you come back to this in 2 months and you go, gosh, how's my performance looking historically? And you realize you didn't turn it on, you don't have to worry because we turned it on for you. So you'll be able to come back and be able to see 2 months how you've been performing over time. If I want to look at all of my resource usage, again, across my entire cluster, there's my CPU, there's my memory, and my storage usage. And I can see from my storage, I'm actually using over 60% of my pretty measly 3 terabytes, but you can see I'm getting it from one view. All of this in Honolulu, you notice I didn't switch consoles, I didn't go from console to console, I literally installed one tool and I'm going through all of that. So you can see how we're thinking about modernizing remote management, how we're making it easier to use with Honolulu. With Honolulu on the HCI, this stuff that I'm showing here will support back to 2016, just to be clear. Doesn't go to 2012 R2, 2012, because those versions of server did not have storage spaces direct. Now, we have added new features in the 1709, which we'll get into a second. And I do want to point out that the server manager stuff that I showed you over here, this stuff, server manager, this will go all the way back to 2012. So I can manage server core all the way back to 2012. I can manage server back to 2012. So 012, 012 R2, 016, and later. But it's the hyper-converged specifically that requires at least 16 and better yet, 1709 and later. So with that, I'm going to pass it on over to Klaus. And you get into software-defined storage, sir.
Thank you. So Honolulu, just to tail off that, is one of the big missing features from 2016. So I'm really excited to see that.
I'm really excited because we're going to light up a bunch of the features that you've had in Storage Spaces Direct, that you guys have been working on like crazy, and now we're going to make it simple to use. That's why I'm excited about it.
This is awesome. So let's take a look under the hood for the storage of what we're going to do. You're going to see these things light up in the insider builds as they roll out. So the first thing, this is the #1 requested feature that we got. Data dedupe in Storage Spaces Direct. So what you expect to see that we can get 30 to 50% data deduplication rates with file servers, 50 to 70 for VDI scenarios, and more than 90 for backup scenarios.
Who doesn't want this, huh?
Right? So how do we do dedupe? So data deduplication has been around for a while. Most implementations are block-based, which means I have to find a block-aligned exact copy to dedupe. Our deduplication is implemented at the file system layer. What that gives us the ability to use variable length deduplication, which improves on the deduplication rates you can actually get out of a system like this. And when you connect the deduplication engine with the REFS file system, which is what we use in Storage Spaces Direct, and REFS is actually aware of the kind of technology the data deduplication uses, so we can go complete atomic operations and we can actually get better performance that you would have seen in the past with NTFS and data deduplication. So that is really good. We also enhanced it with something called the data port API. So what that does is that when you're moving data from a dedupe volume to another dedupe volume, say, for example, you're taking a backup of something that is stored on a data dedupe volume and sending it over to another dedupe volume, because who doesn't want to dedupe their backup volumes? We don't have to actually rehydrate the data, send it over, and then dedupe again. No, it'll just be sent over, the chunk matching will go on, and it'll be very efficient in doing the data transport, which again saves network, which again allows the top applications to consume what's left. So this is really cool. Now, the last part about dedupe is that we have integrated it closely into what we call the mirror accelerated parity volumes. So I don't know if you remember, but a mirror accelerated parity volume is where you take, I got some data, I really want to store it efficiently, so I want to parity encode it, which is where I can get 50% or better storage efficiency out of my storage as compared to mirror, which is 33%. But in order to regain some of the performance, I put a little bit of mirror in front of it where the writes are landing, and then later on we're moving it out to the erasure coding. Now guess what? A couple of things. First, the deduplicated data is pinned into the erasure coded tier. What that means, it means that as we dedupe, it won't go through the cache and pollute the cache. It won't go through the mirror tier and basically just to be moved out to the parity tier later. It goes straight onto the parity tier. So that's super important. The second one is that while the dedupe of our dedupe implementation is schedule implemented, so it will run every so often per the schedule, you can optionally turn on what we call nearline optimization on the data rotation. So if you know how these volumes work, whenever the mirror fills up, we're moving that data, erasure coded out into the parity tier. We're actually looking at the data and deduplicating the data as we move it out, which is going to give you nearline data rotation. Oh, data deduplication. So I have a little short demo here where we, I got to make it play, I guess. Yes, now it's going. We have a little demo here where we have a couple of volumes in a system. One is, as you can see, with data deduplication, and one is without data deduplication. We stored the exact same content, and as you can see, it's REFS based. So there's the REFS support. It's 3-way mirror, and both volumes are created with the exact same size. We have the exact same content stored on both of them. One of them is without data deduplication, so it takes up the majority of this volume. In this case, it's over 183 gigabytes, and causes the systems to throw a critical alert because you're about to run out of space on this particular volume, and you want to do something about it, like increase the volume size, etc. If we go back to take a look at the volumes again, and we look at the other volume, we'll see that in this case, the data deduplication engine has run, and it takes up very little space on this particular volume. In this case, it's about 10 gigabyte of capacity. All right? And if you ask dedupe how efficient was that, it'll tell you that it was about 94% data deduped. Now, this was a very good case in that the data was a bunch of copies of Windows, which is very efficient to dedupe. But let's move on. The second feature I want to talk about is storage spaces direct device support. So you probably know that we support hard drives. You know, the spinning rust that sits out there has been going for 20 years. SATA SAS connected. We got SSDs, just like you will find in most servers today. I have already made the spiel on NVMe, which is a better SSD, effectively more efficient SSD. But in the upcoming releases, we're going to introduce support for what we call, or what the industry calls, storage class memory. This is essentially storage that is attached, non-volatile storage that is attached directly to the CPU memory bus. And why is that important? It gives you a significantly lower access overhead. So if you look at this chart and look at the scale, it's not a linear scale, right? Look at the hard drives, the SSDs was significant improvement over hard drives, but look at the SCM, the storage class memory improvement over SSDs. I expect this to fundamentally revolutionize what storage looks like for a number of latency-sensitive workloads. For example, SQL Server and others. I mean, look how close it is to traditional DRAM. So the way we support storage class memory in Windows is essentially we support it in two operating modes. One, it can be operated as in block emulation. Basically, it looks like any other disk device. Or we can operate it in direct volume access, or DAX, which means we have a zero-copy file system on top of it. And that is actually the most efficient mechanism to get to the storage class memory storage. However, it does require you to write your application differently. So initially, and there is a hint in the word initially, we will support storage spaces direct using block emulation. And you can use storage class memory either as a cache or capacity in a storage space direct system. So take a look at the configurations. So the most simple one is to simply use an array of storage class memory devices as capacity in your system. You could couple that with NVMEs or SSDs, where you create some volumes that come from storage class memory and other volumes that come from SSD. This configuration, we actually worked quite a bit with the HPE and their partners around doing a SQL data warehouse workload on top of a configuration like this, where we put the transaction log and the tempDB database on the storage class memory devices, and we put the rest of the database on the NVMe devices. And what we saw was up to 3x the performance just by changing out the hardware like that, compared to pure NVMe. You can also use, for more generically, just accelerating I/O for all applications that are not storage class memory aware, by simply using the storage class memory as a cache in front of NVMe devices or SSD devices. This is the configuration that Dell is showing in their booth in the expo hall, where they run a set of storage class memory devices over NVMe. And what you see there is you see the I/O latency for read is in the mid-100 microseconds, and the writes is in the about 400 microsecond range. So while we talk millisecond I/O latencies now, we're talking microsecond latencies. And we got more work to do. We're clear that there's more work to be done in the network and in the stack to even bring that lower and closer to the actual device performance. So I want to do a quick demo, and I got to start that as well, of a system. This is a system with the HPE system, where we got 6 servers in this particular configuration. So these are the HPE ProLiant Gen 10 servers. You can see here, we got 6 of them. They're actually configured as a storage system, storage spaces direct, with the scale-out file server on top. And then there is a big honking SQL server sitting outside of that is just driving storage I/O. You can see there is 3.74 terabytes of storage class memory in this particular system. And if you go take a look at the actual drives, you can see we have a bunch of the SSDs, which are the NVMe devices, all working as capacity. And we got all the storage class memory devices also working as capacity out here. And if we go in and look at one of them, we can see how this particular storage class memory device is about 20 gigabytes in size, and it's of the type storage class memory, and its location is a DRAM socket, right? Because that's what it really is. All right. Now, resiliency. So we have done a couple of things to improve the resiliency, or give you more options to use resiliency. So the first one is that we're introducing something called scope volumes, which basically means a volume scope to a subset of the nodes in the cluster, and I'll talk more about that in a second. The second one is we're introducing something called marginal drive handling. So while storage spaces direct is really good about handling a drive, say, the drive works, awesome. The drive has failed, awesome. But there's a whole bunch of gray in between these black and white states. And that is when drives sort of behaves correctly, but not quite. So we're doing a bunch of work to better detection of those types of cases, and then especially around when the drive nears end of life, it can exhibit very interesting behaviors. So we built some improvements to be resilient to more of those scenarios and fence off the device so it doesn't disrupt the primary workload. But back to the scope volumes. in order to present and display to you how scope volumes work, let's first talk about how the normal volumes work, the default volumes. So we distribute a volume across all nodes by default. And there's a reason we do that, and there was a deliberate design, is that we wanted all nodes to contribute to the I/O performance as well as the repair. And you do that best when you have the most drives in play. Now, a scope volume is when you contract that volume, say, this volume can only go on certain nodes in the system. So in this case, I took that volume and said, you can only go on server 1, 2, and 3, which means that no drive in 4 and 5 will host data for that particular volume. And why are we doing that? We're doing that to give you the opportunity to say, hey, the volume will never be impacted by events on these other nodes. So you can actually have both of these nodes fail, and I still got all my 3 copies of the volume up. Now, it is important to notice that when the volume needs to repair because of drive failure, it can only repair on the nodes in the volume scope, which means that the repair operation will likely take slightly longer than it would in the default volume. So notice that we give you a choice. You can do one or the other, and there is no right size fits all. It depends on what you're trying to achieve. The last piece is that, so the mirror accelerated parity volumes. So if you go look at it, you say, well, compared to pure mirror, we see about a 4x improvement in performance using a mirror accelerated parity volume, which is great. The challenge is there's still quite a bit of ways up to what mirror performance is. So we're working hard to make that gap smaller. And some of the key things we're doing is we're improving the rate of data rotation. So how fast can I move the data from the mirror portion of the volume out to the erasure-coded portion of the volume. The second one is about data compaction. As a volume like this will naturally fragment over time as I overwrite data, we're compacting the data to give more free space to operate with, which means that we can drive the volume much closer to full than we could with 2016. So we expect that we will get a much better performance on the mirror accelerated parity. It'll still not be like full mirror, but it's getting much closer. Now, remember last year how we ended the presentation, if you were there? We talked about something we call Project Kepler-47. Kepler-47 was a project that came about inside of Microsoft by Dan and myself. It really was about how low can we go. How many of you actually heard about that last year or have seen it this year? All right, a good portion of you. So the whole promise, as I said, was how low can we go? So what did we do? We basically went onto Newegg and bought a bunch of parts. So we did a garage project in Dan's office, putting together 2 systems. And you can see there's a photograph of last year's conference that sit right there, where we bought some sheet metal and some power supplies and the DRAMs and the low-end CPU, et cetera, to create a 2-node proof of concept, right? Because we wanted to say, how cheap can we make a branch office or a remote office where you don't need the 4 nodes, where you don't need the thousands or hundreds of thousands or even millions of IOPS that we can deliver. And one of the key pieces is that the networking actually turned out to be quite a bit of cost, because you need 2 10-gig adapters, roughly $350, $400 a piece. You need a 10-gig switch, which costs, I don't know, an arm and a leg, and maybe your firstborn. So we actually worked and figured out, can we use Thunderbolt? And Thunderbolt 3 turned out to be a really good networking solution for Windows Server. So we reached out to Intel and said, hey, can we get the Thunderbolt adapter certified on Windows Server? And we got there, right? So now we actually have, working with data on, they actually productized the concept into a system that we can actually show. So in their case, it comes down to $9,000 for both nodes, including the drives. And you get an Intel Xeon processor, you get 64 gigabytes of memory, 10 terabyte of usable storage, and actually up to 60,000 IOPS, which I will say is much more IOPS than most branch offices will need. It's more IOPS than most businesses will need, medium-sized businesses. And we use the Thunderbolt 3 at 20 gigabit a second of throughput. What you probably didn't know, if you look at the efficiency of Thunderbolt, it is actually even more efficient on the CPU than regular Ethernet is. It is not quite what RDMA is, but it sort of slots nicely in between the two. So that is really nice. And there is two options. There is a hybrid version where you have SSDs and hard drives, and there is an all-flash version as well. You can still see it. If you haven't already seen it, you can see it in the Data On booth, or you can see it down at the Microsoft floor. There is a big sign that says Kepler 47. You go there. I'm having problems with this.
Okay. Anyway. Oh, by the way, we got some cool shirts we're going to be passing out. If you were paying attention, real quick question, we'll be asking some trivia in just a minute to pass out some free shirts. But please do evaluate this session. My name is Jeff Woolsey, and this is Klaus Jorgensen. I hope you enjoyed this. So a couple things to think about of what you've seen here. We've talked briefly about recap some of the things in 2016, but you're seeing what's coming down in the Insider's preview. Start tossing some of these out, Klaus.
Yep.
You've seen what's coming in some of the future in the Insider's preview. In fact, right now,
you gotta come closer. I am.
REFS and dedupe. You've seen a whole bunch of the performance new capabilities coming down the line in Storage Spaces Direct, and there's going to be so much more. Please join the Insiders program if you haven't. Make sure that you start giving us feedback. Please download the Honolulu preview. Start giving us feedback. Start playing with the Storage Spaces Direct and the management in Honolulu, as well as taking advantage of what's new in 1709. So with that, just want to say thank you guys very much, and we'll be throwing out some shirts while we got them.